A very good morning to my lecturer, Dr. Shami Hayan Sanusi. I am Thailand from group number 8. Will be present about our group assignment 3. First of all, let me introduce my group members, which is Prem Kumar, Dilvin Anand Thailand, Vivekananda, and Vitesh Chandran. And now, let us move to the content. The items that will be presented is, for the introduction will be presented by Thailand. For brief results from calculation method is by Dilvin. Brief review on validation method chosen by Prem. The demonstration of validation procedure is by Prem. Discussion on conclusion and validation results is by Vivek. And the conclusion will be concluded by Yutesh. For the introduction, objective. The first is to perform analysis using iteration method on lowest and highest natural frequency for nephrin and sorbutane. Second, to obtain the mode shape for nephron and sorbutane. Third is to validate the results using modern tools such as eigenvalue and eigenvector calculator or MATLAB compiler. Next, we'll be looking at expected result. First, sorbutane is expected to be selected. Number 2, this is because sorbutane as a low resonance transmissibility amplification. Third, sorbutane as a superior damping coefficient over a very high temperature range compared to any other polymer. Number 4, low transmissibility means less harm to components which are sensitive. The fifth, isolation at large frequency ratios also shows a vibration isolation capability. Apart from that, lastly, sorbutane has low creep rate compared to other polymers, rubber, nephron, silicon. Unlike fluid-based shock absorbers or foam products, sorbutane absorbs shock efficiently for millions of cycles. For the next, I'll pass to my team member.
Good evening. So my name is Dilvin, and now I'll be just explaining about the results based on the metric iteration method and the validation method. So if you can see here, this is the first, which is the lowest natural frequency for neoprene, and we're also looking into the sorbitol. So the general equation for neoprene and sorbitol to be used is K inverse times M times X equals to H nu. So the number of iterations that used for neoprene is 6 iterations, and the normalized x mu is 0.669 1.000. The formula you use to calculate the Wn is equals to square root of 1 over x normalized, and the final answer for eigenvalue is Wn equals to 43.59 rad per second. As you can see here, this is the mode shape, 0.669 being x1 and 1.000 being x2. Here is the sorbaton. As I mentioned earlier, general equation is the same number of iterations, 6 iterations. You can see here the final answer is slightly different. It is Wn equals to 57.07 rad per second. The mode shape is the same, which is 1.000 and 0.669 for x1 and x2 respectively. Over here, we look into the highest natural frequency for neoprene, which is the same general equations. Number of iterations is the same, which is 6. But here we have the values, the normalized values as 0.974 and 1.000. Formula used to calculate Wn is equal to square root of x normalized will give us the value of 106.46 rad per second. And the mode shape here we have a negative and positive graph. The highest is 1.400 and the lowest is negative 0.974. This is for sorbaton. Same general equation. Number of iterations 6. The normalized values are also similar, but the final answer for eigenvalue is 139.37 rad per second. Same mode.
A very good evening to our lecturer Dr. Shami. My name is Prem and I'm here to present about the demonstration video of our validation method. After we obtain results from our manual calculation of standard metric iteration method, we chose MATLAB as our modern tool usage to validate our results. To find the eigenvalue and the eigenvectors from MATLAB, we have to choose a method called power method algorithm, which is you insert our matrix and our trial factor in the coding to find the eigenvalue and eigenvectors. Okay, in our case, for highest natural frequency, we have to insert k times m inverse S matrix A, and this x is our trial factor, which I used -2.1 and 0.9. So for example, for our highest natural frequency, I enter our values here, which is 12840, -6420, -9840, 9840. Alright, now you have to copy this whole coding, run your MATLAB, you have to choose new script and paste it here, and now your coding is ready to run. Press your run button. Before that, you have to save your file. Save it. Once your coding run, you can see values to enter in the command window of MATLAB. So you have to enter your dimension of the matrix, which is 2, the tolerance used. In my case, I used 0.01 as my tolerance, and the maximum number of iteration that I used is 15, and enter. Then you will get your eigenvalue and eigenvectors for your corresponding matrix and trial factor. For the lowest natural frequency, you have to go to the script, edit back your matrix here, which is 1.55 exponent -4, 1.017 exponent -4, 1.55 exponent -4, 2.033 exponent -4. Now you have to run the coding, and once more you have to enter your dimension again, tolerance, and your maximum number of iteration, and you will get your lowest natural frequency result for eigenvalues and eigenvectors. Repeat the same step for the other material. That's all from me, and thank you.
Good afternoon. Today I am going to present about discussion of my group project. The tables above show a complete net result of obtained of natural frequency and mode shape derived from both metric iteration method and validation method. According to the table, Soboton has the highest value of eigenvalue for both lowest natural frequency and highest natural frequency compared to neoprene. However, neoprene has the highest value of lowest natural frequency obtained by the validation method, whereas Soboton remains the highest natural frequency obtained by the validation method compared with the neoprene. The mood shape value obtained from the metric iteration method and validation method for the both materials were same. Therefore, the mood shape graph for both materials are plotted as the same pattern. The mood shape values obtained for the both materials by the metric iteration method are slightly vary from validation method in decimal points. Therefore, the difference might be occur of some errors. The table below shows the percentage relative error between the values of obtained by metric iteration method and validation method for the both natural frequencies. Next is the justification of material. From the result we obtain, the suitable material to be used as isolator pad is Sorbitol material. There are several reasons to choose Sorbitol as the best material. Firstly, Sorbitol has the highest natural frequency and higher stiffness coefficient compared to neoprene material in order to reduce vibration of the stackable washer and dryer. Besides that, Sorbitol is also known as a good isolator which consists of thermosol and polyether-based material. Therefore, it is good with shock absorbent and vibration damping and isolator. Thank you.
My name is Yutesh. My metric card number is CD170193. So today I would like to talk about the conclusion of our project. So we already at our objective are achieved by using matrix iteration method to obtain the neoprene and Sorbotane and valid results using eigenvalue and eigenvector. To analyze lowest and highest natural frequency, we carried out using iteration and MATLAB. Sorberton has highest frequency compared neoprene. It's occurred due to viscoelastic nature of sorberton. Finally, our result was proved through matrix irritation calculation as well as through MATLAB compiler. Thank you. That's all from me.